All right, this is going to be lesson 5 in Unit 1 transformations. This is going to be on combination transformations. And when you do a combination or a composition, sometimes it's called a composition, it's actually when you put two or more transformations together. In other words, you may reflect it and then rotate it. You could dilate it and translate it. So basically pick any two of the 4 transformations that we've practiced, and then you're going to do both of them before you get your final answer. All right, for this first activity, I have pre-chosen some X and some Y points. So take the sheet you have and take a minute to actually copy down the X list and the Y list. And then what we're going to do is we're going to go ahead and put those on our graph. Now remember, the thing about a video, at any time, if you need to pause, if I talk too fast, you can pause the video, you can go back and re-listen, you can fast forward, or you can just watch it all again if you need to. So I'm going to go ahead and plot these points, -1, 1, and then I'm going to actually connect them with a line as I go. So to the next point is -4 and up 1, and I'm going to draw a line segment connecting. Then I'm going to go to -6, 5. So from the center, I'm going to go 1, 2, 3, 4, 5, 6 backwards and up 5. So it pushes me up there, and I'm going to connect it to the last point. Then I'm going to have -6 up 1. -6 up 1 is right here. Again, the last point, I'm going to connect it. -4 up 5 is up there, connecting it. -1 up 5 is up here. And then 0, 3 is here, connecting it, and I'm going to repeat the first point as my last point, and I'm back to -1, 1. Now I hope that you can see that we have a fish, a real simple, boxy looking fish. And now what I'm going to do is I'm actually going to dilate this by a factor of 2. In other words, I want this to be 2 times bigger. So when I do that, I'm actually going to be working with the rule twice every X and twice every Y, or 2 times every X and 2 times every Y. That would make this fish double. In other words, I want to make it twice as big as what I'm seeing right now. And I'm going to reflect across the y-axis, which basically means that I'm going to have a line that cuts down through the middle, okay, which is right here on the y-axis, and everything on the left is going to be over here on the right. So what I'm going to do is I want to end up with a fish that's bigger and on this side over here. So I'd like to actually do both of those transformations at the same time. It is possible to do both of those transformations at the same time by using a combined rule. So the rule for a reflection across the y-axis, okay, if I go to the y side, instead of going backwards to negative x's, I'm actually going to go forwards to positive x's. So my x's are going to have to change sign. So the rule for that is opposite of every x, but the y's stay the same. Okay, so that's just revisiting, looking at my list for the rules for that one. Now what I'd like to do is I'd like to write a combined rule that will actually bring both of these things together. I want to blend everything from one rule and everything from the other rule together. The first one says I'm going to multiply everything by 2, and the second one says my x's are going to go opposite. So I'm going to do both of those. I'm going to make it go opposite and multiply it by 2, and that's what's going to happen to every x. So I've actually pulled and combined both of those together. As far as y's go, pretty much the y's stayed the same at the back, but the first one tells me to double it, so I'm going to make sure that I double it. So my combined rule that should accomplish this in one step is -2x, comma, positive 2y. So now we're ready to go ahead and make our new list of points. So I'm going to make a list of points. I'm going to have a new x and a new y for each one. So for every x, I'm going to multiply times -2. In other words, I'm going to make it go opposite, and I'm going to double it at the same time. So opposite and doubled of -1 is positive, and it's going to be 2. So positive 2. Every y just simply gets doubled, so it's going to be positive 2. And I'm going to do the rule for all of the x's and all of the y's. Okay, this x is going to be doubled and go opposite. So double 4 is 8, and opposite of negative is positive 8. Double 1, I get 2. All right, double and go opposite would make that positive 12, and double 10, we get 5. Double this and go opposite is going to be positive 12 again, and then double the y's is 2. Double -4 and go opposites, positive 8. because I'm multiplying times -2. -4 and -2 is +8. Doubling 5, I get 10. Times -2, I get +2. Doubling 5, I get +10. 0 times -3 is still 0. And then 0 times 3 is 6. Okay, and I'm going to repeat. Opposite of -1 and doubling is 2 and +2. So now I have my new list of x and y points. I'm going to switch and I'm going to actually graph these in red. So I'm going to go over 2 and up 2, and that's my start point. And then I'm going to do the same thing as the last time. I'm actually going to connect to the next point with a line segment. Over 8 and up 2. So here's my next segment. Now I'm going to go over 12 and up 10. That's way up here. Over 12 and up 10, and I'm going to connect. Over 12 and up 2, it's going to be right here. So I'm going to come down and connect. Over 8 and up 10 is way up here, so I'm going to actually connect. I'm connecting in the order, and then I'm going to go over 2 and up 10. It's right here. And then 0 up 6, and then from 6 down. Now, can you tell that the fish actually got twice as big? I hope that you can see. It did get twice as big, and at the same time, it actually reflected to the other side of the y-axis. So I was able to do 2 combinations or 2 compositions. I doubled the fish, and I reflected across the y-axis, and I was able to do that all at once. So this is an example of doing it all at once, and what we practiced here, what we come up with, is we did a combined rule. Okay? It's a combined rule, and my combined rule for this one happens to be -2y, or excuse me, -2x, comma, +2y. All right. For this next one, I've simply chosen to do a much quicker, easier picture. So I've got a triangle, and let's plot those points. A is at -1 and up 1, and I'm actually going to label these pictures as I go. Okay. B is going to be -5 and up 1. And C is +1 and up 8. Okay. So I'm actually going to draw some lines and connect my triangle. So I've chosen to do only 3 points, A, B, and C. Now, what we're going to do this time is we're actually going to do the transformations once at a time. So I'm going to reflect across the x-axis. So the first thing that I'm going to have to worry about is I'm going to flip. I'm going to have to worry about getting this. What's above the line is going to end up below the line. Okay? It's above the line, it's going to end up below the line. Then I'm going to do a 90 degrees counterclockwise. I forgot my counterclockwise. Usually if it doesn't indicate, the default is counterclockwise. Then I'm going to make this thing go this way, and my resulting picture should end up being over here in quadrant number 4. All right? So we kind of see where we're going. The rules for reflection across the x-axis. Well, the thing about x-axis, you can look at your rules list. I'm still going to go left to my x's, but instead of going above, I'm actually going to go below. So in this case, the y's change. So x's stay the same, y's go opposite. All right, that's the rule for reflection across the x-axis. To do a 90-degree counterclockwise rotation, the rule is the y's are going to come to the front and go opposite. The x's are going to go to the back and stay the same. Now, in this particular instance, it's not as easy to see, without maybe some trial and error, how you would combine those 2 rules into 1 rule. So since I can't easily figure out or easily tell you how to do that, we can, and we're going to practice doing a combination one at a time. So I'm going to go basically one picture, use that from picture, and do the third picture. So I'm actually going to have 3 images on this graph when I'm finished. All right, if I start with A, B, C, I'm going to end up with A prime, B prime, and C prime. And I'm going to do my first rule, which is right here. X's stay the same. So my x's stay the same. So A prime would be -1 is my x, B would be -5 is my x, and C prime would be +1 is my x. All right. But in this rule, the y's go opposite. So opposite of positive 1 is -1, -1, -8. So I now have A prime, B prime, and C prime. So I'm going to go and I'm going to put those points on the graph, and this would actually reflect it. So if I'm 1 up, I'm going to be 1 down, and sure enough, that is -1, -1, that's A prime. Okay, 1 down 8, and that is C prime. And then B is once above the line, so I'll be 1 below the line, and that is -5, -1. Okay. Now, I want to keep in mind, that is actually not going to be my final image. I might even just dash that in, because that's kind of like a stepping stone. I actually need to go one more time with it. I need to do something else to it. Now, the other thing I'm going to do is I'm going to do my 90-degree counterclockwise rotation. I'm actually going to put a third image, and so in this case, since I've already got A prime noted, this one's going to be A double prime. This new point's going to be B double prime. See the two marks? C double prime. Now, the one thing I want you to know is we are not going to look at these anymore. So we're not going to use these but one time. All right, do not use these points again. It's almost like they're not there now. We're going to use these points to help us get the new points, A prime, A double prime, B double prime, and C double prime. Oh, what's my rule? My rule says that the y's came to the front and the x's went to the back. The y's went opposite when they came forward. The x's go back and stay the same. All right, so here we go. -1 goes to the front and goes opposite. So that's +1. -1 goes to the back and stays the same. -1 goes to the front and goes opposite. -5 goes to the back and stays the same. -8 goes to the front and goes opposite. 1 goes to the back and stays the same. So now I have my new points. I did not use that first list of points again, okay? I'm actually going from the red triangle to the next new triangle. So I'm going to locate my points. Over 1, down 1. That's going to be A double prime. Notice my two marks. Over 1, down 5. 1, 2, 3, 4, 5. That's going to be B double prime. And C is over 8, up 1. C double prime. This is my final and completed rotation. If I can, I will highlight this one in. Notice that I didn't, my red one, the one I put in dash lines, I did that just to indicate that that is actually just a stepping stone. That's not my final answer. That is just simply where I ended up after the second transformation. But this is what it looks like whenever you do one at a time. We did not do it all at once. We did it one at a time. All right. Now, the next sheet we have is a practice sheet on writing combined rules. And this is not something that you're going to see a lot of, but there is value in actually practicing this. There's also some things we need to point out. Okay. All right, let's talk about dilate factor of 3. Dilate factor of 3. So if we dilate a factor of 3, first thing I'm going to look at is I'm going to start with the rule that says x and y. So if I dilate factor of 3, I'm going to multiply every x by 3 and every y by 3. Okay. Now it's almost like I've already done the multiplying by 3. Now I've got to do what number 2 says. Translate or slide 4 units to the right. Now that's going to be when we do something with the x's, and down is when we do something with the y's. 4 units to the right is like +4. Okay? 5 units down is like subtract 5. Now remember, if you're going to +4 and then you're going to subtract 5, I've already got 3 times x. That's what started there. There's already there first. Okay? So my combined rule is going to bring these two things together. So I have to keep my 3 with my x, which was already there. Then I'm just going to add the 4. My 3 already has a y because that was the first thing I did, and then I'm subtracting 5. This is my combined rule to accomplish dilation of factor 3 and translation of right 4 down 5. Okay, let's see what happens when I do the rule in reverse. So the first thing I'm going to do this time is actually opposite of what I did in A. So we're going to translate right 5, or excuse me, right 4. So it would be x at 4, comma. 5 down, that has to do with the y's, so it's y minus 5. So I'm actually doing in opposite order what I just did in part A. Now it says that I'm going to dilate factor of 3. So that means I'm going to take 3 times every x, right? And 3 times every y, all right? But if I take a look, I don't have just a plain x. I have x plus 4. I've already done something to my x. So it's going to be 3 times something, comma, and 3 times something. All right, remember, it's not just my plain old x. X already has plus 4, so I have to actually keep parentheses x plus 4. Here I need parentheses, it's going to be y minus 5. In this particular case, because of the order in which we did the transformation, I'm going to end up multiplying 3 times x and 3 times 4. That's going to give me 3x plus 12. This is going to give me 3y minus 15. This rule and that rule, we did the same things, but we did them in opposite order. So here's the question I want you to pause to consider. Does order make a difference for this? Well, I think you can see here I'm adding 4, and up there in the part B I'm adding 12. So there's a no doubt that this is a big fat yes. Okay, a big fat yes. All right, let's take a look at C and D. C and D. Okay, we're going to rotate 180 degrees counterclockwise. It doesn't really matter if it's counterclockwise or clockwise, but rotating 180. Look at your rules list. The rotation for 180 is opposite of x and opposite of y. Then it says dilate by a factor of 2. So I'm going to, I guess I should write this over here, opposite of x and opposite of y. If I dilate factor of 2, basically what I'm going to do is I'm going to times everything by a factor of 2 on the x's, times everything by a factor of 2 on the y's. So that's going to be like 2 times every x and 2 times every y. And then if I combine these two together, I've got to do a negative and times by 2, so that's negative 2x, a negative and times by 2 for y. So this would be your combined rule for rotate 180 and then dilate by a factor of 2. Okay, let's do part D. Dilate by factor of 2. This time we're going to do that first. So I'm going to do 2 times every x, 2 times every y. Then it says add the rule for this. Okay, remember, rotate 180. We just did that one up there. It's opposite of every x and opposite of every y. I'm doing the same thing in part D that I just did in part C, only I'm doing it in opposite order. So I still have to try to blend or combine the two rules together. And the first thing I'm going to do is multiply by 2, and then I'm going to have to make it opposite. Well, that gives me negative 2x. Multiply by 2 and then make it opposite, still negative 2y. Now what we want to do is we want to compare the two rules. Does this rule and this rule look exactly the same? And they should. It looks like I do have a parenthesis there that might make it look, simply need to put my parenthesis in the front. So when I compare my rules, in this case, they are exactly the same. So does order make a difference for this? And the answer is no, it really doesn't. So some transformations, the order matters. Some transformations, it really doesn't. So let's go back and look. When we did the dilation and the translation in part A and B, we got a big yes. Okay, we got a big yes. This part right here, it says yes. That tells me that there's a difference. Now, what I did is I actually had to put this into practice. When I was kind of investigating this and learning it and trying to get it fixed in my mind so I could teach it, what I had to do was I had to try to show or figure out how to explain it. So this is what I came up with. So if I do a size plus a reflection, it doesn't really, order doesn't necessarily matter. A size plus a rotation, order doesn't matter. But when you slide and translate, order does seem to matter. So it does depend. So when I do the first one, it says shift to the right and down 3 and then dilate. So I'm having to do one thing first. Then I'm doing the other, just like we practiced with the rule. I just want to kind of highlight the final point. And I even did all my points. So you can see A, B, and C, A prime, B prime, C prime, A double prime, A, B double prime, and C double prime. Take a look at the position of where triangle A, B, A prime, double prime, C double prime, where that one ended up. Notice that it is not in the same place as this other one. A double prime, B double prime, C double prime ends up in a totally different place. So even though I did the same two things, I just did them in opposite order, and I did them one at a time. I did not blend the rule. I kind of did them one at a time, trying to show everything. Notice they are not the same. So sometimes the order in which you do the transformations does make a difference. All right. Now I'm going to ask you to pause the video and try the next few. Then you can restart the video and check your answers. All right. Just going to run through this. Reflection across the line equals x. If you dilate, multiply times 4, x's and y's. Across the line y equals x. Y's come to the front, x's go to the back. So if I do both of these things at the same time, I got to multiply everything before and switch the order. So I'm going to have 4 with y and 4 with x. That is my combined rule. All right, letter F, reflection across the y-axis. So I want to go opposite of x's, y stay the same. Dilate factor of 5, 5 times every x, 5 times every y. What I'm going to do is I'm going to try to combine these two together. So everything I have to do in the first one, so the first one goes opposite, and it has to be multiplied times 5 with an x. X stays in the front, y stays in the back. Here, everything just gets multiplied times 5y. Rotate 90. That one is opposite of y, because they do switch places. And then translate left 5. So that's what the x is. I'm going to subtract 5, so I'm going to have to subtract 5. And then up 2 would be with the y's, and that's plus 2. Now here's the one. This is probably the trickiest one on the whole page, because what you have to understand is this is now my new x, right? It's the old y, because the y's came to the front, went opposite, but now that's in the place of the new x's. So I'm going to take that new x's, which still has a y label, and I'm going to subtract 5 from it. Y's are at the back, x's is showing at the back, but that's actually the new y. So I'm going to take that y, which still shows an x, and add 2. That's probably the trickiest rule of the bunch. But it's simply because y's and x change places first, then we translated it. Okay, so y's were in the front because they're a new x. Reflect across the x-axis. So if you go above the x-axis to below the x-axis, the x's stay the same, y's change. Then we're going to translate right 2, that's plus 2, and down 4, which is minus 4. So if I plus 2 and minus 4, I'm going to end up with x's plus 2. Notice that x's are in the front position, they didn't change. And the opposite of y was done first, so I have to keep the negative with y, and then subtract 4. Now, it's not easy, it's not possible to always do, for in my opinion, a combined rule, but there are some that you can do. You will have to do a combined or a composition of functions for your poster project, which counts as a test grade. You're welcome to use one of these rules, or you're welcome to write it your own. You're welcome also to check with the teacher and ask for help. Okay.